Welcome to Yogi's lecture. So in this session, we can discuss about the vector analysis in electromagnetic field. So vector analysis is a mathematical representation of any physical quantity can be presented either in scalar or a vector. So scalar vector அப்படிங்கிறது நம்ம சொல்ல போகிறோம். So and then ஸ்கேலார்னா என்ன அப்படின்னு பார்த்தோம் அப்படின்னா, ஸோ ஸ்கேலார் இட் இஸ் அ குவான்டிட்டி தட் ஹேஸ் போத் மேக்னிடியூட். ஸோ மேக்னிடியூட் மட்டும் இருக்கிறத நம்ம வந்து ஸ்கேலார்னு சொல்கிறோம். தட் இஸ் எக்ஸாம்பிள் டைமு, மாஸ், டிஸ்டன்ஸ் எக்ஸெட்ரா. ஸோ வெக்டார், ஸோ இட் இஸ் அ குவான்டிட்டி தட் ஹேஸ் போத் மேக்னிடியூட் and directions. So example velocity, force, field intensity, so and etc. And then if we go for a vector algebra includes vector addition, vector subtraction and vector multiplication. And then now we go for a vector addition. So it is the operation of adding two or more vector together into a vector sum, that resultant C which is equal to A vector plus B vector. So this is a parallelogram method. So here we have a B vector and here we have a A vector. So this resultant is nothing but a C. So C is equal to A vector plus B vector. So this parallelogram method, otherwise we can set head to tail method. Here we have this arrow represents the head and end point is represents the tail. So the head of A connected to a tail of B. So this head of A which is connected to tail of B. So இதுதான் வந்து head and tail method சொல்றோம். So here we have a properties. So the properties of vector addition. First it want to satisfy the commutative law. So A vector plus B vector which is equal to B vector plus A vector. And it want to satisfy the associative law. A vector plus B vector plus C vector which is equal to A vector plus B vector plus C vector. And then it want to satisfies distributive law. So K of A vector plus B vector which is equal to Ka vector plus Kb vector. And then vector subtraction, it can be done in terms of vector addition. So vector addition வச்சே vector subtraction எப்படி பண்றோம் அப்படின்ட்டு. So A vector minus B vector which is equal to A vector plus minus of B vector. So here this is A vector. So up this dotted line is represent the positive B and this straight line is representative minus B. So which is resultant A vector minus B vector. So here A vector plus minus of B vector, that is here. So the properties of vector addition also satisfies. So vector addition also satisfy here. So same commutative law, A vector plus B vector which is equal to B vector plus A vector, and associative law A vector plus B vector plus C vector which is equal to A vector plus B vector plus C vector, and distributive law K of A vector plus B vector which is equal to Ka vector plus Kb vector. So and then we go for a vector multiplication. So vector multiplication further classify two classifications. One is scalar, or that is otherwise known as dot product. So vector or otherwise known as cross product. So here we want to discuss about the what is meant by dot product and cross product. So scalar product is represented by A vector dot B vector. So we already said it is otherwise known as dot product. So A vector dot B vector. So it is defined as the product of the magnitude A vector and B vector and the cosine of the small angle between them. So this is A vector dot B vector, which is equal to AB cos theta AB. Here this is B vector, this is B vector, and this is A vector. So the angle between the A and B is nothing but theta AB. So here we can represent by cosine. So cos of theta AB. So we know A vector, which is equal to AX and AY plus AZ. Similarly, B vector is equal to BX BY plus BZ. So here this A term is nothing but a unit vector, and this is the magnitude. So A and B is nothing but a magnitude here. So final A vector dot B vector, which is equal to AX BX plus AY BY plus AZ BZ. The properties of scalar dot product. So here also want to satisfy the commutative law. A vector dot B vector, which is equal to B vector dot A vector, and distributive law A vector dot B vector plus C vector, which is equal to A vector dot B vector plus A vector dot C vector. So the properties of unit vector, here the same term AX, AY, which is AZ, which is all are 1. So other combinations are 0. AX, AY, AZ, and AZ, AX, which are 0. So and then we can discuss about the cross product. So cross product A cross B vector. So the cross product of two vectors A and B is a vector quantity whose magnitude is the product of AB sin theta AB, which is perpendicular to the plane containing A and B vector. This A vector cross B vector, which is AB sin theta AB in normalized plane AN vector. Here this is A vector and this is A cross B vector and this is B vector. So the angle is theta AB. This is perpendicular to the normalized plane AN. So here the cross products are represented in a matrix form: A vector cross B vector, AX, AY, AZ, and this is the unit vectors, and AX, AY, AZ, BX, BY, BZ. So here we all know, so A vector value and B vector value, we already know this value as a common term. And then properties of cross product. So it is not a commutative law. A vector cross B vector not equal to B vector cross A vector, and it is not a associative law. A vector cross B vector cross C vector, which is not equal to A vector cross B vector into, that is not cross C vector, but it is a distributive law. So A vector cross B vector plus C, which is equal to A vector cross B vector plus A vector cross C vector, and for A vector cross AY vector, which is equal to AZ, and this one AX vector cross AY, which is equal to AZ, AY cross AZ, which is equal to AX, and AZ cross AX, which is equal to AY. So and then a negative term. So if you want to change the position, AY cross AX, instead of AX AY, we change the AY cross AX means, which is equal to minus AZ, and AZ cross AY which is equal to minus AX, AZ cross AX cross AZ which is equal to minus AY. So next one is differentiation. The differential vector operator del is called del or nabla. So this del which is equal to dou by dou x into ax vector and plus dou divided by dou y into ay plus dou divided by dou z into az. So now we go for a gradient. The gradient of any scalar function is the maximum space rate of change of that function if the scalar v represents electric potential. So this del v represents the potential gradient. So del v which is equal to dou v divided by dou x into ax plus dou v divided by dou y into ay plus dou v divided by dou z into az. So the del v is also said as grade v. So and then divergence. So the divergence of a vector A at any point is defined as the limit of its surface integral per unit volume as the volume enclosed by the surface shrinks to 0. So the del A which is equal to limit 1 divided by V over the surface integral A into n vector into ds. So the del dot A which is, so we know del value here, so we know the del value and we know the A value ax ay az az. So substitute these del value and ax, so we get del dot A which is equal to dou ax dx plus dou ay dou y plus dou az dz. So the del A which is otherwise known as divergence A. So next topic is curl. The curl of a vector A at any point is defined as the limit of its surface integral of its cross product with normal over a closed surface per unit volume as the volume shrinks to 0. Here we can represent the curl A which is equal to limit V tends to 0 1 divided by V over the surface integral S n vector cross A vector dz. So del cross A we can derive from this matrix. So we want to get the Ax and so multiply dou Az divided by dou y minus dou Ay divided by dou z, and then dou Ax divided by dou z minus dou Az divided by dou x into Ay plus dou Ay divided by dx minus dou Ax divided by dou y into Az. So this is curl cross A which is equal to curl A. So thank you.